Welcome back to Math 109, Plain Trigonometry. In this video, we're going to take a look at the different transformations of the sine function. So, as our textbook writes it, standard form of a trigonometric function, and I'm going to use the sine function here. All the transformations I'm doing also apply to the cosine. C plus A sine of bx minus d. We're going to take a look at the different things this does. Now, in the in-class activity, I had you graph several functions like this, some of them with the different variables being trivial, but they were all somewhat of this form. So the first thing that I can do is look at A. So we noticed, looking at these functions in class, that tells us how much the graph goes up and down from its center. This is formally known as the amplitude of the function. We actually have a formal definition of that. Is that the amplitude is equal to the max value minus the minimum value divided by 2. Now, we only apply this to periodic functions. If we applied it to any old function, we'd have a lot of functions out there with infinite amplitude that are also in no way periodic. The other big one that's going to affect a lot of things is the b term here. That has to do with the period of the function. If we make it negative, it's going to flip across the x-axis. Of course, if we make a negative, we saw that flips it upside down. But these are also difficult to see because all that's going to do is be more of a phase shift, which we'll talk about later. But changing b in terms of absolute value is going to change the period of the function. A bigger b means a shorter period. A smaller b means a larger period. So, the formula that we get for that is that the period is equal to 2 pi divided by the absolute value of b. And that's something we noticed. We were paying attention in the in-class activity as well. With C, as you noticed with the in-class activity, if I add a bigger number for C, that means my graph's going to move up. So, that'll be our vertical shift. I'm putting a summary over here of what we have so far. A is equal to the amplitude. B is, I'm going to use a slightly different symbol here, is inversely related to the period. So that's saying inversely related. C is equal to our vertical shift. And then the final thing we want to look at is what d does to the function. So that one we noticed, if I added bigger and bigger numbers inside the parentheses on this problem, we noticed that the graph shifted to the left. Well, we can think of it as positive numbers shifting to the left, but usually when we think of positive numbers in the coordinate plane on the x-axis, we're shifting to the right. So for that reason, we use minus d in our formula rather than plus d. so that when we put a positive number in for D, it's shifting to the right. But D is going to deal with our horizontal shift. So like I've stated, I'm not going to ask you to graph functions on your exam, but I do expect you to know these relations and what it's going to do to your function. So, we'll take a look at some applications in the next class of this. In the next video, we're going to start looking at the other 4 trigonometric functions.